Assalamu alaikum and welcome back with few more questions related with the univariate functions, integration of the univariate functions. So this is the question 5 of the assignment over here, and you can see that this integrand is present in the form of two different factors. Okay, so we simply have to first of all we just try to simplify this integrand and then we apply integral on it, because presently you are studying the preliminary integration, and basically integration are of several types, including partial fractions, by part, substitution, and so on. But in the beginning you simply apply integral on basic format, and this is the question related to that basic integral. So over here you simply have to analyze that this integrand isn't that much simpler for us, so we have to simplify it first. So let us now help out this integrand by multiplying these two factors. So let us now multiply first term of first factor with the second factor whole minus the second term of the first factor multiplied by the second factor whole. Okay, so I hope you're familiar with the signs, because it is minus, plus, minus, and minus, minus. That's how the plus comes. So now simplify each term. It becomes x squared and cancellation. Minus 5x cubed minus 2. It becomes x left, plus 10x squared. So now just arrange the terms according on the basis of the powers present on the variable. So the x cubed variable is going to be written first. And you can see you're having 2x squared, so it becomes 1x squared plus 10x squared gives you 11x squared, and then comes minus 2x. So we have just arranged the terms on the basis of the powers. Okay, so this is the simplified form of this integrand. Now we are going to apply the integral here. So integrating both sides, we get when we have integrated both sides, and I have just applied integrals on each term instead of applying whole, so it looks like this. Then I have just taken out the constant, or what you say, the coefficient of the variable outside the integral sign. It looks like this. Now over here you can see that this is the, over here you can apply here the formula of your integral of xn, that is n power x plus 1 upon n plus 1. Yeah, so on each integral, as all of them are representing the integral of xn format, so everywhere in all these three integrals you're going to apply the same formula of integral of xn. So that's how it is going to be solved. Plus some constant. As you are dealing the indefinite integrals, you're not having the limits, upper and lower limits are not here, so this is an indefinite integral, so you're going to put the constant sign here. Okay, so remaining thing I can write over here. So integral of whatever the integrand, I'm not writing whole, so let me write, because it looks awful if I just try to skip that. So over here the answer comes out to be this thing. So it is minus 5 upon 4 x power 4 plus 11 upon 3 x cubed, okay, minus 2 upon 2x squared plus c. This 2 and 2 gets cancelled. So finally you're having the form of some constant, and this is your answer. That's how you solve. Okay, so let's have one more example. Okay, so this is the question 8 of your assignment, and over here you can see the integrand. It is not simplified, so we have to solve the integrand first. So you can see that, how about if I simply open this part, this term of the integrand, 2x minus 1 whole square with respect to this basic algebraic identity. So I can use this formula here. So it looks like this. If this is your a and this is your b, then it comes out to be a squared minus 2a, this is your b, plus b squared. Okay, and you close. So now I'm having 4x squared because this is a whole square outside, so it is going to be applied in both these things. So that's how it looks like, minus 4x plus 1. Okay, now I'm going to multiply this x with all these three terms. It comes out to be this, 4x cubed minus 4x squared plus x dx. Okay, now let me apply this integral individually on all these three terms. Now take out the coefficient outside the integral. Okay, now once again you can see that this is the format of integral x power n. So you're going to use the same formula once again, and it is x3 plus 1 upon 3 plus 1. That's how it looks like, x2 plus 1 upon 2 plus 1, and this is x1 plus 1 upon 1 plus 1 plus a constant. Okay, so this is now 4, becomes 4 upon 4 x power 4 minus 4 upon 3 x cubed plus 1 upon 2 x squared plus c. You can simplify the first term. Now this is the final form that should come. Okay, so presently in this assignment questions you are chiefly dealing with the polynomials present in the integrand. Okay, so that's how this integral is going to be solved, and this is your answer. Now let's see one more example. Okay, this is question 7 of the assignment. Oh, sorry. So you can see the integrand is now once again a little bit tricky. Not tricky, it's just practicing. So you are going to multiply this x power half with the square root over here. Remove the square root, you get power 1 upon 2, you know that. So this x power half is going to be multiplied with these two terms inside the parentheses. So this is it. So I'm going to multiply it. It looks like this. Sorry, it's 1 into 1 dx. So over here the powers are same, the base are same, and once the base are same and they're getting multiplied, you simply add up the powers. This is the major property of your exponents. And this x power half getting multiplied with your 1, you simply get x power half over here. Okay, now just solve the powers, taking out the LCM at this place. Okay, it's 5 by 2 therefore. That's it. Now you apply the integral individually. You apply the integral now individually over here. It becomes something like this. Now once again, it is the format of integral of x power n. Apply the formula of x power n, and it is x power n plus 1 upon n plus 1 minus x power half plus 1 upon half plus 1. Because of the indefinite integral, we put some constant for the compensation. Okay, so now I'm solving. I'm taking out the LCM. It gives you 7 by 2. I don't think so that I have to do that thing. You're good enough to handle. Okay, so just 3 by 2. It's 3 by 2 plus some constant. So on inverting, you get this 2 upon 7. X power 7 by 2 minus 2 by 3. X power 3 by 2 plus some constant. You can take 2 outside of the common. So it is 1 upon 7. Well, you are not restricted that you can take out 2 common definitely out. It is just to beautify your work. That's it. So this is how you solve this integral. Okay, this is the whole process, and this is your answer, and that's it. Now further in in the next video, we are going to discuss the integration by simple substitution method. Okay, hope you have understood these examples, and if you find these videos helpful, just subscribe my channel and hit on the like and share it with your other learners so that it becomes more pervaded here and there. Okay, take good care of yourself, and see you then with the next video after a short while.